Good day. So this lesson will be an introduction to pneumatics. So in this in these lab sessions we'll be using this workbook. So we'll be completing these exercises using the FLUIDSIM software by Festo. So I've already uploaded a video showing you now on how to install this software. And after install it, when you open it, this is how it looks like. And then you are gonna go to new, gonna create a new, and then you're gonna get something like this. So as you can see, there's a line dividing the white tab. So on the left hand side of the line, that's where you can draw your circuit. On the right hand side, you can't do anything. So don't put your circuit components on the right hand side. Only draw on the left hand side of the blank tab, right? And then on the far right side, you'll get another tab that's named hierarchical view component library, right? So here, this is where you'll get your components that you'll use when you are throwing your pneumatic circuits, right? And then, since, as I said, we'll be using these textbooks, but for the purpose of this lesson, I'll be using this PowerPoint, right? It's exactly the same. It's exactly the same to what's on the workbook that I just showed you and I've uploaded for you, right? So we can get started, right? So in exercise one is named pressing cheeses, right? So, like from the image on here, it seems like they are using a pneumatic cylinder to press cheeses and retract, right? But we'll understand the process as we read the instructions that were given to us, right? So the training aims of the exercise is to be familiar with the function and setup of a single acting cylinder, and also be familiar with the setup of a 32-way valve that's normally closed, and then be able to sketch and recognize various types of actuations used for directional control valves, and also be able to explain and set up direct actuation. So before we get started, right? So there are two types of cylinders, but now, like the first one, it's called a single acting cylinder. So a single acting cylinder has one in, so it has one inlet and outlet. So the inlet also serves as the outlet. So the compressed air, it flows into the piston's chambers, and then allowing it to advance to the forward position. And then when the switch is released, the air flows back through the same the same hole that in which it came through, right? So you should read up more on the single acting cylinder according to these notes, right? So anyway, moving on, we have a three-way valve. So a three-way valve has 3 ports and 2 switch positions, right? So the function of a normally closed, it means that it's closed. At its original position, it's closed. So it doesn't allow air to flow through. At a point where you press on the three-way push button or valve, that's when it opens up, allowing air to flow, and then allowing your actuator to advance. Your actuator in this case would be your cylinder, right? So now, going back to the process, they're saying in a cheese manufacturing process, pneumatic cylinders are used to press the cheese into molds, and then develop a control system that can be used to carry out this process, right? So the description of the process is given as the cheese, the cheese is, the cheese is, the cheese is inserted by hand, and then they're saying when a push button actuator is pressed, the piston rod advances and presses the cheese into the mold, right? And then they are saying the push button is held down until the procedure is complete. And then the fourth step, they are saying when the push button actuator is released, the piston rod retracts, allowing access to the mold, and then the cheese can then now be removed, right? So now, in the description of the process, right, it is where you will get your information about the circuit that you're supposed to design in the context of the types of patching that you're supposed to use and how the process is supposed to be initially set up. For example, if you look at this, they're saying when a push button actuator is pressed, the cylinder advances, right, and presses the mold. So this statement, it would tell you, or it's supposed to tell you, that now the actuator, which is the cylinder, it is initial position. It's supposed to be at the back end or retracted position, and then at a point where you press the push button, that's when the cylinder is supposed to advance. So that should tell you that you're supposed to use a normally closed straightaway valve, right? And then they're saying now, if you look at this as well, they're saying at statement number 3, they're saying when the push button actuator is held down until the pressing procedure is down. So now this should tell you that the type of push button that you are using, it's not latched, given that you have to hold it down to allow a continuous supply of air. At a point where you let it go, it cuts the supply of air to the cylinder, which is or actuate, right? So now the statement saying when the push button actuator is released, the piston rod retracts, allowing access to the mold, right, which I just covered. So the parameters of this exercise, they're saying we should use a single acting cylinder, and the saying the cylinder must be pneumatically controlled using a manually operated valve, right? So now, going back to our FLUIDSIM, so when we're designing our circuit, right, we need to, the fundamental components that we need to have are a compressor. So this is a compressor. If you maybe wish to see what it looks like, you can just right click and then go to component photo. So this is what a compressor looks like, right? Then if you also want to get a description about the compressor, you can right click and then it will give you, and then go to component description, and then it will give you all of the information you need to know about a compressor, right? Okay, so now to build our circuit, we need a compressor which is used to supply air into our circuit, right? And then we need an air service unit, right? So an air service unit, it cleans the air of any particles, or it purifies the type of can I say, maybe I can say the type of air or type of compound that go into our circuit. So usually it's compressed oxygen, right? So maybe it filters out other particles in the air, because air is composed of many different compounds, right? So it filters out to compressed oxygen, and then that's the air that flows into a circuit, right? So now to connect our components, we just drag from here to here, right? So every component, a pneumatic circuit can't run without air, without a compressor, as it supplies the air to a circuit, and then also we need to have an air service unit so we can get a clean supply of air, right? So this is what an an air service unit looks like, right? So now, going back to exercise, as I said, there are different types of valves, right? So now, there's one, there's two, and then there's three. So we'll focus on these three, right? So as I said, there's normally closed and normally open. So now I discussed that a normally closed push button doesn't allow the supply of air, right? Up until a point where you press it, that when air flows through, because it is in an initial position, it's closed, right? And then a normally open, it's always allowing air to flow through up until a point where you press it, that's when it cuts the supply of air going into the circuit, right? And then this is a selector switch, right? It's the difference between a selector switch and these two is that the selector switch is latched, right? So we'll be covering it in a later exercise, right? So now we have to, so since now we have these two, we have to choose which button are we going to use according to how they describe the process to us. And again, going back to the description of the process, since they told us that the cylinder only advances when the push button is pressed, and as I said, the normally closed push button, it only allows air to flow through when it's pressed. So now I can conclude that we'll be using a normally closed 3-2-way, right? And then the parameters of size were saying we should use a single acting cylinder. So this is what a single acting cylinder is. So if you'll notice, so if I may also divert again, you'll notice that there are two types of cylinders. There's a single acting and a double acting. So now we'll come back to the differences between these cylinders, but the main one that I want to emphasize is that if you look at a single acting cylinder, which is this one, it's a spring loaded cylinder, and then the double acting one is not a spring loaded one. So which means if every time this cylinder advances, right? So every time you make it advance, it will go back on its own due to the effect of the spring, right? But the double acting cylinder is not spring loaded, so it won't go back, right? So okay, moving on. So now we connect our circuit. So now from the air service unit we go to one, right? Because the air has to go through one, and then it comes out of two into our cylinder, right? So now if we simulate the circuit, so now you can see now the air is not going through up until a point where I press and hold it down to keep it advanced. So you can see now the cheese is being pressed as I'm holding it down, and then as soon as I let it go, it retracts back to its original position. So that will be all for this video. I'll continue exercises on the next videos. Thank you.